Okay, well, good morning, everybody in the US, and good whatever time it is wherever you are. So I have a slight correction to make on my own presentation. So I had titled it AI Observability, How to Fix Issues with Your ML Model, but I realized that actually this wasn't entirely accurate because what I'm going to talk about today isn't just fixing issues with a machine learning model, it's fixing issues with a machine learning system. And you might be wondering, like, what is a machine learning system? You've probably heard about machine learning models, things like neural networks and linear regression models, all of these machine learning models. But actually, models make up a very small part of what it takes to get machine learning into production. This is a screenshot from a really famous Google paper from 2017 by D. Scully called Hidden Technical Debt in Machine Learning Systems. And as you can see, machine learning code actually makes up a very small part of a machine learning system. There is a lot of other stuff that's happening in machine learning rather than just the simple, input to a model makes its predictions. You need to be able to collect your data. You need data verification systems. You need a whole serving infrastructure so that the inferences being made by the model are able to be passed to whatever application is surfacing them. There's all of this stuff that happens that goes above and beyond simply a machine learning model and really is required to get a machine learning system into production. And what I'm going to be talking about today is how to fix issues with both machine learning models and with machine learning systems as a whole. So let's go over a quick agenda before we dive into it. So I'm going to start off by talking about the need for machine learning monitoring, but then I'm very quickly going to pivot to share that machine learning monitoring isn't enough. You have to go above and beyond monitoring. And in order to do that, I'm going to talk about observability. But first, defining what observability is, and then letting you know how you can get there. And then finally, I'm going to get to the meat of today's presentation, the reason that everybody's here, which is what to do when a machine learning model degrades and how you can change a machine learning system to prevent machine learning model performance degradation or model failure. So let's start off by establishing a very simple fact, which is that you need machine learning monitoring. And the reason that you need it is because models degrade, right? And they degrade because of two things, either because of data drift issues, so stuff like covariate shift or target drift, where the real world is changing, which causes the machine learning model trained on historical data to no longer accurately represent the real world, right? If we train a model that represents pre-COVID data and it's on a variable that's relevant to COVID, very likely our model has gone out of date and needs to be retrained in order to take into account this data drift. The other set of issues that result in model degradation are data quality issues. So these types of issues primarily come as a result of like bugs, errors, typos, issues that humans have made in the process of building the machine learning system, usually in the data pipeline upstream of the machine learning model. So these types of data quality issues might be type mismatches or an introduction of a lot of null values. There's lots of different data quality issues. So monitoring your machine learning model and monitoring your machine learning system is really key to picking up on these data quality issues that cause model degradation and model performance failure. So without monitoring, the key observation to make is that you're only going to find out about issues from your customers. It's only when somebody tells you that, hey, I'm getting weird recommendations from Netflix, or hey, my Uber ETA was way off, that you'll know that there was an issue with your machine learning model. But with monitoring, you can be proactive instead of reactive. You can get ahead of the problem instead of having to wait for your customer to tell you that there's something wrong. Now, I'm not going to talk about machine learning monitoring too much in today's presentation. If you want to learn more, I've actually given several talks specifically on machine learning monitoring, both how to do it and why it's important. And you can find these talks if you just Google my name, Danny Leybzon, and then machine learning monitoring. But really, monitoring is only the tip of the iceberg. And in order to debug issues with machine learning systems, you also need observability. So when your model performance is degraded, when monitoring has told you that there's something wrong, you need to know what it is that you need to do in order to resolve the problem. right? And monitoring really only helps you detect a problem, not solve a problem. And in order to solve a problem, you actually need observability. So that's why we have observability in today's conversation, because observability is what's required to debug the model, to debug the machine learning system, and to fundamentally resolve whatever is causing model performance degradation or model failure. This next slide that I have points to a classic CI/CD flow diagram, right? It goes through the processes, the circular processes required in DevOps to deploy applications that are robust, reliable, that are scalable, all of these things. And the CI/CD diagram can actually be mirrored in machine learning, where instead of thinking about the machine learning model lifecycle as a linear flow, where you start by gathering data and then you finish by deploying your model, understanding it to be cyclical. So you start by building your model and then you test your model. When you're satisfied with your model, you deploy your model, you evaluate the model as it's been deployed, and then at some point you decide that it's time to rebuild your model, to train it again so that you can test it and then redeploy it. And as you can see, it's really a life cycle. It's not a linear process that ends with the deployment of the model, but rather continues on and on in order to maintain the loop that's required to make sure that the model stays performant. Okay, now we've kind of like touched on observability, but it's useful to have a firm grasp on what the term means. So observability is insight into the state of a system by looking at its outputs. And really this definition of observability comes not from machine learning operations, not from MLOps, not from development operations, not from DevOps, but actually from control theory from the 1950s, where observability was being used in order to be able to study what a complex system was doing based on what was coming out of the complex system. And a key insight to make that we're going to circle back to a little bit later in the presentation is that observability requires a knowledge of historical state, because we want to be able to compare the present outputs to historical outputs to know what's going on with the system. And it's really vital to understand that this observability, this insight into the state of a system by looking at its outputs, enables postmortems and analysis. And it's really the key to being able to debug problems with machine learning systems, because only with insight into the state of a system can you solve any kinds of problems that might be occurring within a machine learning system. So without getting too in the weeds of it, the secret to observability, which DevOps figured out a long time ago, is actually logging, right? And we see this in the classic 3 pillars of observability for DevOps, which is metrics, traces, and logs. Metrics, traces, and logs are all different types of artifacts. They're all different outputs for a system that can be used to understand the interior of the system. Now, the system that is being represented by metrics, traces, and logs is a software 1.0 system. It's like a classic software application. But in the world of machine learning, in the world of software 2.0, it's not enough to keep track of metrics, traces, and logs. You really want to be logging data, and you want to be understanding what's happening with the data, both the data going into the machine learning model, the predictions being made by the machine learning model, as well as the performance data, the output of the machine learning model, the predictions being made relative to the ground truth. And obviously, you only get to know performance data if ground truth is available, but it's important to track the outputs even if ground truth is not available. So with all of this in mind, you can see that there is a very obvious overlap between MLOps and data ops, right? Because MLOps, and specifically monitoring machine learning models, requires not just information about machine learning, but really information about data. Ultimately, we're monitoring data, and it's just a very specific use case of data monitoring. And AI observability, insight into the state of a machine learning system, really only happens at the intersection of data ops and MLOps. And we'll circle back to this again later. So this need to be able to log data, to be able to monitor data, Hey, I think I might have gotten booted out, but I'm back again. So I guess I'll share my screen once more.
Yeah, you can start sharing now.
We noticed it and it's okay. Yeah.
Okay. Can you guys see the WhyLogs slide again?
Yes, we can see.
Perfect. Okay. So the key insight for this slide is that there's this open source library WhyLogs, which allows you to create statistical summaries of data sets, which are called WhyLogs profiles or data profiles. And these profiles have similar properties to logs produced by other software applications. They're statistical summaries of data, which means that they allow us to keep track of the historical state of the machine learning system in order to be able to describe and understand and detect any kind of changes in the system. WhyLogs have a couple of really cool, useful properties. The first is that they're descriptive. So they're really accurate summaries of data sets. They say stuff like the distribution of the data, the number of missing values. They tell you the data type and they infer the data type, but be it a string or an integer or a float. And all of this information describes a data set in a very lightweight way. And that's the second key property of WhyLogs. The fact that these logs, these WhyLogs profiles are much lighter weight, they're much easier to interact with than raw data. Because you can take even data sets that are on the order of gigabytes or terabytes and compress them down to megabytes with WhyLogs while retaining a lot of the information entropy, retaining a lot of the really useful information about the data set. And then the last property of WhyLogs is their mergeability. This is a really useful property. It allows us to take two WhyLogs profiles, combine them together, and create a new profile that's kind of the sum. It describes the information of both of the prior profiles. And the cool thing about mergeability is that it enables a lot of really useful use cases for us. So it enables distributed compute. So if you have like the same machine learning model running on two different systems, you can combine the logs from these two systems to create a single view of the entire system. If you've got a streaming system, you can merge together the logs related to different periods of time. If you want to be able to zoom in and out in your analysis of a time period, you can combine together the WhyLogs profiles for 7 days into a week, for 30 days into a month, for 365 days into a year, and kind of get a holistic view based on whatever level of time granularity you want. So these WhyLogs profiles are really useful because they allow you to get observability, to get monitoring into the state of a machine learning system. Now, finally, we can talk about, what do you actually do when your monitoring system connects or picks up on some kind of performance degradation, some kind of issue. And I'm going to posit to you two different approaches. The first is the human in the loop approach, and this is the most common approach right now. And then I'm also going to talk about automated MLOps, and this is pretty cutting edge stuff. So in the automated MLOps section, we're going to be talking about what's going on at the frontier of machine learning observability and AI observability. So the first is human in the loop, right? Where we've got a model in production, it's generating logs. These logs are getting sent to an AI observability platform, something that takes these logs together and then generates alerts for a machine learning engineer. And then when a machine learning engineer gets an alert, they actually have to go into the AI observability platform and analyze the logs in order to get some kind of insight as to what's going on in the platform. The key thing that they get from this is the ability to remediate some kind of problem, right? They've found an issue with the machine learning model or the machine learning system, and they can remediate it, such as by retraining the model. So with this human in the loop analysis, we can see that there's the ability to analyze the cause of system degradation, see whether the model performance failure or model performance degradation is caused by a data quality issue or a data drift issue. They can take some kind of remediative action, such as fixing a broken pipeline upstream or retraining the model on new data. And then they can rinse and repeat, right? When they've fixed the problem, they can go away and wait for another problem to come. This works fine right now. It's very manual. It's very rote. It's very human oriented. And the real issue with this is that we sit at the intersection of two fields that are very highly focused on automation, right? Computer science, software engineering, when people say software is eating the world, what they're really saying is software has this incredible ability to automate things that used to have to be manual. So software engineering is a practice that really instills automation. And then machine learning takes it a step further and allows you to automate things that really required human intelligence by introducing artificial intelligence and automating things that used to be requiring of human intelligence. So, if we're doing machine learning in software engineering systems, and if we're existing at the intersection of these two fields that are so highly focused on automation, doesn't it make sense to similarly automate whatever processes we're using in our systems? And that's why we have this concept of automated MLOps. So I know this diagram is a little bit more complicated and involved than the diagrams we were looking at earlier, but you'll notice that it's only a single diagram instead of three separate diagrams. So in this diagram, we've got a data pipeline that is generating both logs as well as data, and it's sending the logs to an AI observability platform, sending data to a model in production. Now, this machine learning model in production, it's going to be making some inferences, some predictions, and then it's going to be sending logs about its predictions to this AI observability platform as well. This AI observability platform can collate the logs from both the data pipeline and the model in production and can send an informational alert based on the data that it's getting from the data pipeline and the model in production to some kind of intermediary process. And what this intermediary process can do is it can take in this alert, this information about the data pipeline and the model in production from the AI observability platform. It can take in this alert, and then it can decide on what kind of remediation it might need to do if it detects some kind of problem. So if it detects that there's a problem related to data drift, it can know to retrain the model and to put a new model in production that can take into account new data. And then alternatively, if it detects that there's some kind of data quality issue, it can roll back a data pipeline to a previous version of the pipeline that didn't have this problem. And the real value of having this intermediary process either roll back this pipeline or retrain the model is previously this remediation that had to be human driven can now be automated. So it can happen much faster, and it can happen without taking any kind of bandwidth from a human being. So again, we can see that AI observability has to sit at the intersection of data ops and ML ops, because the remediation, solving any kind of problem that you pick up on in machine learning monitoring has to go beyond just retraining your model, and you have to have the ability to fix problems with the machine learning pipeline, with the data pipeline that's feeding data into the machine learning model. So this automated MLOps process really takes the human out of the loop. It takes the human out of the process. It automatically triggers rollbacks when new pipeline changes are introduced, or when new pipeline changes introduce data quality issues, or it can automatically trigger retraining when model performance degradation gets past a particular threshold. So we can contrast this with the more manual, the more human in the loop process, which required a human being to try to solve these problems. So that's the